So good morning, everyone, and welcome back to the class. This is lecture number 14, and we are into the last part of this topic, which is known as graphs. So we will be dealing with graphs in this class and probably finish it by the next class. Before getting on to graphs, let me ask you, do you know what are graphs? Have you gone through graphs in maths in your lower standards? Yes or no? Anyone knows what the graphs are? You must be doing it in maths as well. Yes or no? Graphs are a part of physics as well as maths. They are taken from maths, and we use a lot of graphs in physics. Now, whenever we talk about graph, let us see some important things that we know about graph. Every graph has a x and a y axis. Now, this x is known as the independent variable. X is known as the independent variable, whereas your y is known as the dependent variable. Everyone knows this? Independent and dependent variable. Yes or no? Independent variable, why do we call it independent variable? For example, if I write an equation y is equal to 3x plus 4, and if I ask you to draw a graph for this, what will you do is you will start putting the value of x. You will start putting the value of x as 0, then x as 1, x as 2, x3, and get the value of y, and then you will plot the value of y, and then you will join them with a free hand. That is why what you have done is that you have given arbitrary values or independent values or whatever you wish to x, and similarly from those values of x, you have calculated the value of y. The value of y is not in your hand. It's a dependent variable, it's dependent on x. The value of x is in your hand. You can give it any value. Therefore, this x is known as independent variable and your y is known as dependent variable. And I always write this like this. Y is equal to fx. Y is a function of x. Do we understand this? Y as a function of x. So you can give any value of x. Your x becomes your independent variable and your y becomes your dependent variable. Now, whenever we call any graph, every graph has a name. How do I call a graph? I always say y-axis first and then I say x-axis. So the name of this graph will be known as y-x graph. This will be a graph between y and x. For example, if I plot r position here and t time here, this graph will be known as a RT graph. Position time graph. Position is plotted on the y-axis and time is plotted on the x-axis. So remember, whenever you call any graph, it is always called y-axis first, then x-axis. Do we understand this? Yes or no, everyone? Now, you also know probably that this y is equal to 3x plus 4, or you have any equation which is in the form of y is equal to mx plus c. This equation represents what? This is the equation of what? This is the equation of a
slope of a line.
Why is what? This is the equation of a straight line. I knew you are giving the right answer, but you are answering the question before the question is asked. Now I am going to ask that question. What is this m known as? M is known as the slope of this line. Do we understand this? And slope of a straight line is always constant. It always remains same. Yes or no?
Yes, sir.
And how do we find out this slope m of the straight line? If I, let us say, have a straight line like this, tongue, 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 how do I find the slope of this straight line?
y2 minus
y2 minus y1 by x2 minus x1.
The better way of saying this would be, you are right, that I find out this angle theta. that this straight line makes with x-axis, and then I find the value of tan theta, and this tan theta is the slope of this straight line, which basically tells everyone how steep is this line. Slope. You have encountered slope all your life. Slope. Steepness of a line, steepness of a graph, steepness of a curve is determined by slope. What is the slope? If the steepness is high, if it is very steep, the slope is very high. Actually depends on your angle. If your angle increases, your tan theta also increases and your slope becomes very high. Tan of 0 is 0, but tan of 90 is not defined because it is very large. That is what we call as the slope of the line. We can define it by the steepness of the line. Do we understand this? Not sleepness. Steepness, I hope no one is sleeping. Steepness of the line. How steep is that line? If it is a line, it is the steepness of a line. If it is a curve, it is the steepness of the curve, which may not be constant, which may be different at different times. Do we understand this? Yes or no? I'll give you 2 minutes to note it down. Note it down, fatafat. We'll move ahead then. Any doubts at any point in time? Clear it now itself. Don't wait for eternity that I will clear my doubt only after this is done or only after that is done. Clear your doubt now itself. Have we noted it down? Yes or no?
No, sir.
Okay, shall we continue?
Yes, sir.
Okay, now let us talk about some very basic things about graph, and most of the graphs that you are going to see are going to be straight line. Most of the graph that you're going to see will be straight line. Let me call this as the x-axis. Let me call this as the y-axis. The first graph, the simplest of them could be drawn like this. I would draw a line like this. A line like this. Now, what all things you can say about this graph? Here, as you can see, the value of x is changing. X is changing from x1 to x2, but the value of y is remaining constant. Do we understand this? The value of y is remaining constant. What things can we understand about this graph, which is the blue graph? Let me call this graph as graph number 1. What things do we understand about graph number 1? Yes. What are the things that we understand? What about the slope of this graph? What about the slope of this graph? Tell me fast.
0, sir.
Slope, which is m, is equal to 0. This graph is parallel to x-axis.
Axis.
What is the equation of this line? Every line has an equation. So equation of this line is y is constant. Yes or no?
Yes, sir.
X changes. but y is constant. Do we understand this? Yes or no? Slope of this graph is 0. It is parallel to x-axis. Y does not change even if the value of x changes. Do we understand this? Everyone? Note it down. These are the things that we can understand about this graph. The blue graph, which is graph number 1. Have you noted this down?
Yes, sir.
Note it down? Okay. Now let us talk about the other extreme. This graph, if I talk about this graph, this is a horizontal line, right? Horizontal line which is parallel to x-axis. This graph has no steepness. It is a flat line. It has a slope 0. If I make it vertical, then I have this graph, which is graph number 2. Do we understand graph number 2 now? What all things can we say about this graph? What about the slope of this graph?
0.
What about the slope of this graph?
That is x-axis.
What about the slope of this graph? The slope of this graph is infinite, or we call it better undefined. It has got no slope. It is undefined slope, because as you can see, the value of x does not change, but the value of y changes. Now, if we go back to the previous case, when I talked about this graph, the steepness of this graph, one thing I did not mention here was how were we finding out the tan theta of this graph. So let me just write it here. If this value of x is x1, this value of x is x2, this value of y is y1, and this value of y is y2. How do I find the slope of this graph? How do I find the slope of this graph? I find the value of this side, which is, how much is this side? This is y2 minus y1, yes or no? Then I find the length of this side, which is x2 minus x1. I hope all of you understand this. This length, the vertical length, total length is y2. This much is y1. So this becomes y2 minus y1. Do we understand this? Everyone understands this? Similarly, this length from here to here, from here to here, from here to here, it is x1. The entire length is x2. So this part becomes x2 minus x1. If I have to find out the value of tan theta, m, which is tan theta, which is constant, can be written as y2 minus y1 divided by x2 minus x1. Do we understand this? Now, I hope you have noted this down. Note it down. Now, as soon as you come into graph number 2, the slope of the graph is y2 minus y1 divided by x2 minus x1. But in this graph, what do you see, bacha? That x2 minus x1, there is no x2, there is no x1, there is only one x. So x2 minus x1 actually becomes 0. Something divided by 0 is not defined. Tan of 90 is not defined, because we have to find out the tan of this angle. In this case, it was tan of 0. Tan of 0 is 0, but tan of 90 is not defined. So the slope of this line is not defined. Do we understand this? Yes or no? This graph is going to be parallel to y-axis. X is equal to constant, but y changes, and this will be a vertical line. For a vertical line, the slope is infinite, not defined. Since it is not defined, this graph actually is not possible. It means that x and y are not dependent on each other, because even if x is not changing, y just keeps on changing. Do we understand this? Yes or no? Everyone understands this? I'll give you 2 minutes to note it down. Let me know once you are done. Are we done, bacha?
Sir.
Okay. Yes. Now, we have seen the two extreme graphs. One is the graph which is horizontal. One is the graph which is vertical. Two extreme graphs. Horizontal graph, vertical graph. What about the next graph? How would the next graph look like? And the next graph would look like exactly what we had drawn in the first case. The next graph looks like this. The next graph looks like this. Now here what is happening is x1, this is x1, this is x2. So as you can see, the value of x is changing. It is increasing. And you look at the value of y. And what all things can you say about this graph when you move from point A to B? We always move like this in the increasing direction of x, because that is what we are more concerned about. Okay. What all things you can see about this graph? Let me call this graph as graph number 3, continuing from where we had left the previous case. Yes, what all things you can say about graph number 3? What all things you can say about graph number 3? Tell me first. When x increases, what happens to y?
Increases, sir.
When x increases, y also increase, or you can say x is sort of directly proportional to y. Yes or no? If I find the
Yes, sir.
slope of this graph, if I find the slope of this graph m, which is nothing but equal to tan theta, this slope is going to come as positive. Yes or no? So this is a graph with positive slope. Since it is a straight line, this slope is constant as well. It does not change. It is a constant. How do we understand whether a slope of a graph is positive or negative? This first line tells us if the slope is positive or negative. If the value of x increases, When I say x increasing, it means it is moving along this direction. And the value of y also increases. When I say increases, it means moving along positive y-axis. We call that graph as graph with positive slope. Do we understand this? If it is a straight line, the slope is going to be constant as well. Positive slope, constant slope, that is all that we need to know about this graph. And if I have to find out this slope, you can also write it as y2 minus y1 divided by x2 minus x1. As you can see, the value of y2 is more than y1. The value of x2 is more than x1. So this will be a positive number. Tan theta is positive. M is positive. Theta lies in the first quadrant or the third quadrant. Do we understand this, everyone? That is all about graph number 3. I'll give you a minute to note it down.
Completed, sir.
Okay. That makes us to move to graph number 4, and I hope you see graph number 4. Now something has changed in graph number 4. When I see x increasing, the value of y decreases. Yes or no? So what all things you can say about graph number 4? What is the first thing that you can say about graph number 4? The value of x is increasing. Do you see the value of x increasing from x1 to x2? When I'm moving from point A dash, I'm calling it different to B dash. The value of x is increasing, but the value of y is decreasing. Yes or no? Such a graph is known as a graph with negative slope. A graph with negative slope. Here, if I find, again, it will be y2 minus y1 upon x2 minus x1. If I find this value, x2 is more than x1, but y2 is less than y1. So it will be negative divided by positive, and the answer will automatically come negative. Do we understand this? Yes or no? No or yes? The slope of this graph is also constant. Do we understand this? Okay. This is what you need to know about straight line graphs. Please note it down. Have we written it down?
Yes, sir.
Okay. Then that takes us to the various types of graph that we are going to encounter. And what is the first graph that we are going to encounter? The first graph is known as position time graph. Sometimes people will also call it displacement time graph, but that is not probably the correct way of calling it. It is basically a position time graph. What will be plotted along what? Where will I plot the position and where will I plot the time? Where will I plot the position and where will I plot the time?
Position on y-axis and time on x-axis, sir.
Position will be plotted on y-axis and time would be plotted on x-axis. That is absolutely correct. That is what I must do if I want to draw a position time graph. So that is what I'm doing. I have my time on x-axis and my position r on y-axis. Now this particle can be moving along x-axis, it can be moving along y-axis. So whatever it is moving on, whether it is x-axis or y-axis, it is always plotted on the y-axis. Do we understand this? It's just the position. Time is the independent variable. Time is plotted on the x-axis. The other thing, x or y, wherever it is moving, z, it is always plotted on the y-axis. That is how I draw this graph. And the first type of graph that you will have would be like this. Now, what all things you can tell me about this graph? This graph is graph number 1. Tell me what all things you can say about this graph number 1. Now, remember, whenever we talk about a position time graph, or for that matter, sometimes they call it displacement time graph, you must also always understand that velocity is dr by dt. Do we understand this? Yes or no? I'm not writing it in the form of vectors. I'm just writing its numbers. Or we also know that this average velocity is change in position r2 minus r1 divided by t2 minus t1. Yes or no? From this thing, we understand one of the velocities is instantaneous velocity and the other velocity is average velocity. When I look at average velocity, when I look at instantaneous velocity, one thing is very clear. We can find something from the position time graph of a particle. Apart from the position, obviously, because it's a position time graph, you look at the time, you look at the position, you obviously find out where the particle is. But apart from finding out where the particle is, you can also find one more thing about the particle. And what is that thing that you can also find out? Apart from the position. Looking at time, I can find out where the particle is. Because it's a position time graph, you are supposed to find that out. But looking at these two things, you can also find out some more. You can also get some more information about the particle from the position time graph. And what we can find out? You can also find out its velocity from the position time graph. The slope of what? Slope of RT. What do you mean by R? What do you mean by T? R means position, T means time. The slope of RT graph will always give me the velocity of the particle. Do we understand this? I don't see boys in the class raising hands, only girls. Okay. Slope of position time graph gives me velocity. Now, there are two types of velocities. One is instantaneous, one is average. How do I get the instantaneous velocity and how do I get the average velocity? How do I get the instantaneous velocity and how do I get the average velocity? To get the instantaneous velocity, you find the slope at any point. If I want to know the instantaneous velocity at this point. You find the slope at this point on the graph. Do we understand this? So if I say, someone asks me what is the velocity at 2 seconds, you look at 2 seconds, you look at the slope. Okay, this is the velocity at 2 seconds. Do we understand this, or this has gone above or at saying bye bye? I'm going, don't worry about me. To get the instantaneous velocity, you find out the slope at that point. To get the instantaneous velocity at 2 seconds, you find the slope at 2 seconds. To get the instantaneous velocity at 4 seconds, you find the slope as 4 seconds. To get the instantaneous velocity at 6 seconds, you find the slope of the graph at 6 seconds. Do we understand this? How do I get the average velocity? The average velocity is between 2 points. So 2 points will be given to you. For example, 1 point will be given here, T1, point number 1. 1 point will be given here, point number 2, and you will be asked, what is the average velocity from A to B, 1 to 2? What do? You find the slope between the 2 points. And how do you find the slope between the 2 points? R2 minus R1 divided by T2 minus T1. It is written. So as you can see, in the average part, there are 2 points already written, but in the instantaneous part, there is only 1 point written. So that is the answer. How do I find instantaneous velocity, or how do I find the average velocity? Do we understand this, or this has gone above or at saying bye bye? So slope of RT graph gives us the velocity. It gives us the instantaneous velocity. It also gives us the average velocity, depending on what slope we are finding out. If we are finding out the slope at 1 point, 1 instant, it is instantaneous. If I'm finding out the slope between 2 points, 2 instant, it is the average velocity. Do we understand this? Yes or no? No, yes. I'll give you 1 minute to note this down. Do it fast. Have you noted it down, beta? Okay. Now let us come back to graph number 1. What all information can we get from graph number 1? Tell me fatafat. What is the information that I get from graph number 1? Tell me fatafat.
Velocity, sir.
What about the position, sir, first? It's a position time graph. So the first thing you must tell is the position. What is happening with the position? The
Constant.
position of the particle does not.
Position is constant, sir.
Position is constant. It does not change. It does not change. Do we understand this? It is at the same position. The position does not change. If the position does not change, that means the particle is at rest. Do we understand this? Slope m is 0. Slope of this graph is 0. Slope of this graph gives me the velocity. That implies velocity is 0. That implies the particle is at rest. Yes or no? Slope is constant. Slope is constant. That means velocity is constant. That means its acceleration is 0. Do we understand this, or this has gone above or at saying bye 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 bye, sir, I'm going. Please don't stop me. We understand this or not? The particle is at rest. It does not move. Its velocity is 0. It does not change. Acceleration is 0. Velocity is 0. Particle is at rest. Nothing is happening here. I hope everyone is noting this down.
Completed, sir.
Then I get to this graph, which is graph number 2. Graph number 2. What we can say about graph number 2? Position is changing. R is changing. But
Time is constant, sir.
time is constant. Without time, time is not, at one instant, it has got many velocities. It is at many places. It is present at many places at the same time. That means its velocity seems to be infinite or undefined. Do we understand this? Because its slope is infinite. Yes or no? Is this graph possible? At one time, can it be present at different places? So practically,
sir.
this graph is not possible. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye? I'm going, I'm going, I'm going. So you will never find graph number 2 in physics. In maths, you may. In physics, it's not possible because at one time it cannot be present at different places. So these are graph number 1 and graph number 2. I hope everyone is noting them down. Yes or no? No, yes. I'll give you 2 minutes to do it. If at any point you think that you have not understood anything, please feel free to ask your doubts now itself before it gets dark. When I say it gets dark, it means it is late. When I say late, it means late in terms of time to ask the question. Same thing we have written previously, same thing now we are writing in terms of position time graph so that we understand how things are related. Let us move on to the next graph. Graph number 3. Again, a graph between position and time. Particle moves from point A to point B. What all things you can say about this graph? Tell me, fatafat. Graph number 3.
Position is changing with respect to time.
Okay. Position is changing with respect to time. What else? When time increases, the value of R also increases. Yes or no?
Sir.
What all things you can say? What all things? M, the slope. What about the slope of this graph? Positive or negative?
Positive.
Positive, sir.
That means what is the velocity of the particle? We're talking about vectors. Positive vector means this direction, negative vector means this direction. What do you say? What can you say about the velocity of this particle?
Positive.
Positive. M, which is the slope, is constant. Yes or no? What can you say about the velocity? Velocity is constant. Velocity is positive. Velocity is constant. Velocity is constant. What you can say about the acceleration?
Zero, sir.
Acceleration is 0. As time increases, the particle position is increasing. Slope is positive. Slope is constant. Velocity is positive. Velocity is constant. Acceleration is 0. Now, since velocity is constant, if someone asks me, Bacha, what is the velocity at this time? Let us say 2 seconds. What is the velocity at 2 seconds? To find out the velocity at 2 seconds, you will find the slope at this point. Yes or no? But It is a constant slope ka graph. So even if you find the slope at this point, or you find the slope at this point, or you find the slope at this point, 1 second, 2 seconds, 3 seconds, are they going to come same or are they going to come different? Huh? Are they going to come same or are they going to come different? Is this such a difficult question?
Same.
Same. They are going to come same. If I find the slope between point A and point B, will it come same as other slope or will it come different? Implies your instantaneous velocity v at any point will be equal to the average velocity because everywhere the slope is same. Do we understand this or this has gone above our head saying bye bye? I'm going. Tata. Sayonara. Okay. This is graph number 3. I'll give you a minute to note it down. Note it down fatafat. There is nothing new here. Yes. What all things you can say about graph number 4? I hope you have done this. Yes or no? Graph number 4 comes into the picture now. What all things you can say about graph number 4? Tell me fatafat. I don't have time to waste. Tell me.
Distance increases. Sorry,
Distance
position
is not there
increases,
in the
time
graph.
decreases, sir.
When time increases, position of the particle decreases. What can you say about the slope?
Negative, sir.
Negative. That means velocity is negative. Yes or no?
Sir.
Slope is constant. Yes or no? That implies velocity is constant. That implies acceleration is 0. Are we getting this? Yes or no? No, yes. If I find the average velocity and if I find the instantaneous velocity, they will come same or no?
Sir.
These are the things that you must remember. Note it down. Stay happy. Noted this down? Comes the next graph. Graph number 6. I am going from A to B. What all things you can say about graph number 6? It's not drawn correctly.
Sir, it's 5, not 6.
It is 5. Number problem. This is graph number 5. What all things you can say about graph number 5? As time is increasing, what about the position? It's increasing, yes or no? What about the slope of this graph? Is it positive? Is it negative?
Positive, sir.
It is?
Positive, sir.
Positive.
That means velocity is positive. Is the slope constant?
No, sir.
Slope is changing. What do you mean by slope changing? Velocity is changing. Now, if the slope is changing, it will be increasing or it will be decreasing. Increasing means graph becoming steeper. Decreasing means graph becoming flatter. Is it increasing or is it decreasing? Is the slope increasing?
sir.
Huh?
Increasing.
Yes, slope is increasing. That implies what? Velocity is increasing. Now, look at these 2 points. Velocity is positive and velocity is increasing. What you can say about the acceleration? Velocity is positive and velocity is increasing. What can you say about acceleration?
Increasing, sir.
No, you can say that acceleration is positive. Do we understand this? Velocity is positive and velocity is increasing. Acceleration must be in the same direction. Do we understand this or this has gone above our head saying bye-bye? This is graph number 5. You'll have 1 minute to note it down. Do it fast. Noted it down? Comes graph number 6. Tell me fatafat about graph number 6. In the same way. Time increases, what happens to the position of the particle?
Gone, sir.
It increases. Anyone understands what I'm saying or am I going
Sir,
too fast?
video gone.
Video gone, sir.
Video gone, sir.
I can't help that, sir, because my video is coming. Beta, can you see that video? The class?
Sir.
Your video gone, sir. That means your problem with the monitor, sir. Please do something about it.
I said was problem, sir.
Yeah, please check it. Okay. Graph number 6. Anyone remembers graph number 6 now? It's there in your head. You can't see it on the board, but it's in your head, right? Yes or no? Answer the following question. The first point is when time increases, the position increases. What can you say about the slope of the graph?
Positive, sir.
Slope of the graph is positive. What does that imply?
Velocity is positive.
Well done. Is the slope constant?
Changing, sir.
Slope is changing. What does that tell us about the velocity?
Changing, sir.
If the slope is changing, it would be increasing or it might be decreasing. What is happening here? Is it getting more steep
Increasing.
or is it getting flatter?
Increasing, sir.
Look at this point. Look at this point. Look at this point. Is the graph getting flatter or is the graph getting steeper?
Steeper, sir.
No, it is getting flatter. Here it is more steep. Can't you see it? Here it is more steep. Here if you go, it has become very less steep. Flat has become, slope is becoming flatter. That means slope is decreasing. This is the graph with increasing slope. Here the slope is very less. As I move up, the slope is continuously increasing. The graph is becoming more and more steeper. Do we understand this? So here in this case, the slope is decreasing. That means what happens to the velocity?
Decreases.
Velocity decreases. What can you say about the acceleration?
Negative, sir.
Yes, acceleration is negative. If velocity is positive, acceleration is negative. That is how you can find out about the acceleration of the particle from the position time graph. Do we understand this, everyone? Let us wait for the class to join so that they can also see this. Two more graphs are left. We'll do those graphs and then probably we'll say bye-bye. Let us wait for 2 minutes. If they do not join back, I will discuss the other two graphs. What will be the other two graphs looking like? Can you draw them and can you tell me how will they look like? Try. That is how you use your brain to help you out. Remember, when the question comes in the examination hall, I'm trying to cover everything that is possible in this universe. Every type of question that is possible, I will tell you. But still, the language of the question, I cannot predict the exact language of the question. The exact language of the question might be somewhat difficult or different. I can't predict that. I can predict what question can come, but I can't predict the language of the question. I can't see it, bacha. Can you bring it close to the camera so that I can see it? I don't have that far distant vision. So you must have drawn the diagram, but I can't see it. Can you bring it closer to the camera? Are? Yeah, that is correct. That is graph number 7. That is correct. That is graph number 7. Okay, so the other class has joined. Now you can see me, bacha. Everyone? I think your voice is muted. Graph number 6. Graph number 6 we were talking about. In graph number 6, when time increases, position increases. We all understand this? First. No, the other class, other class. Do we understand this better, boys? Slope is positive. That means velocity is positive. We understand this? Slope is changing. Velocity is changing. Now we look whether the slope is increasing or the slope is decreasing. Is the graph getting flatter or is the graph getting steeper? What is the answer? Is it flatter now or is it getting steeper?
Flatter.
Well done. That means slope is decreasing. That means velocity is decreasing. Velocity is positive and it is decreasing. Therefore, acceleration must be in the opposite direction. Do we understand this? I'll give you a minute to note down this graph. Then we'll move on to the last two graphs with the class. And I already have the slope, the what? The shape of the graph is already there. T R comes graph number 7. And how do I draw graph number 7? Everyone has drawn till graph number 6, yes or no? Graph number 7, and it looks like this. I move from A to B, graph number 7. Let us talk about graph number 7 and please tell me what is happening in graph number 7. First point, as time increases, what happens to the position of the particle?
Decreases, sir.
It decreases. What does that mean? The slope of the graph is?
Negative.
What does that mean? Velocity of the graph is?
Negative.
Negative. Is the slope constant or is the slope changing?
Changing, sir.
M is changing. What do you say about the velocity? Then velocity is also?
Changing.
Velocity is also changing. Now, if the velocity or slope is changing, it might be increasing, it might be decreasing. Is the graph getting flatter or is the graph getting steeper from A to B? A to B. Is the graph getting flatter or is the graph getting steeper? Getting flatter means slope is decreasing. Getting steeper means slope is increasing.
Steeper.
Look at this point, beta, and look at this point. Is the graph steeper at point number 1 or is the graph steeper at point number 2? Steep means higher slope. Flat means lower slope. Is the graph steeper at point 1 or is steeper at point 2? It is definitely more steeper at point 1.
A.
Yes. So slope of the graph is decreasing.
Decreases.
Yeah, that means the velocity of the particle.
Decreases.
What can you say about the acceleration then?
Negative.
Acceleration is positive. Why it is positive? Because velocity is negative and velocity is decreasing. Particle is moving like this, but it is decreasing. That means acceleration has to be in the opposite direction. The opposite of negative is positive. Do we understand this?
Yes, sir.
Comes the last graph. What will be the last graph looking like? Do tell me fatafat. It will look like this. Graph number 8. Going from A to B. How does graph number 8 look like? Can you tell me about graph number 8? The first thing, when time increases, position decreases. What can you say about the slope of this graph?
Negative.
What you can say about the velocity of this graph?
Negative.
Is the slope variable or the slope constant?
Changing.
Changing. That means velocity is changing. Now, whether the slope is increasing or whether the slope is decreasing.
Decreasing, sir.
Is the graph steeper here or is the graph steeper here? Here the slope is increasing. Do we understand this? Graph is getting steeper, slope is increasing. That means velocity is increasing. What you can say about the acceleration? Velocity is negative and velocity is increasing. Acceleration has to be negative. Do we understand this, everyone? So these are the things that you must remember about the graph. The slope of position time graph gives us velocity depending on the slope. If the slope is constant, velocity is constant. If the slope is positive, velocity is positive. If velocity is constant, acceleration is 0. If velocity is increasing, acceleration is in the same direction. If velocity is decreasing, acceleration is in the opposite direction. How do you find out whether the velocity is increasing or decreasing? You look at the slope, you see whether it is getting steeper or it is getting flatter. Getting steeper means velocity increasing. Getting flatter means velocity decreasing. Do we understand this? Yes or no? No, yes. We will do some questions of this position time graph in the next class, and next class we will try to do velocity time graph as well as acceleration time graph and see if we can wind up the chapter in the next class. If you have any doubts, come up to me, else the class is over from my end. Take care, have a nice day. God bless you.
Thank you, sir.
I hope you have understood everything that we have done in the class. Go through this, please see it once more, and I'm sure if there was any doubt, that would be clear. Don't worry, we will come to the same thing, same graph in the next class, but they will not be RT graph, they would be VT graph, but same thing will happen there. Do we understand this? Take care, have a nice day. Bye-bye.